Hello viewers, welcome back to my Speed Max and Math Electrical for you. Today we are going to discuss out in matrix how to find out the characteristic equation and how to write the eigenvalues. So the basic characteristic equation in any matrix can be determined by using the equation A minus lambda I equal to 0. So where lambda is the eigenvalues. So the eigenvalues are also called as proper values or latent roots or characteristic roots. So let us see what is an 2 by 2 matrix and 3 by 3 matrix. And 2 by 2 matrix is one which consists of 2 rows and 2 columns. So we will represent it by matrix A11, A12, A21 and A22. Easy convenient way we will represent it by A, B, C and D. Similarly for a 3 by 3 matrix, it consists of 3 rows and 3 columns. So we'll name the matrix first row as A11, A12, A13. Second row as A21, A22, A23, A31, A32 and A33. Similarly, we'll represent each and every element of the rows and columns by A, B, C, D, E, F, G, H, I. Now we'll see how to write the characteristic equation for a 2 by 2 matrix, and then we'll see for a 3 by 3 matrix also. As already we described out how to find out the roots of the characteristic equation, in which for a 2 by 2 matrix is given by the characteristic equation as lambda square minus C1 lambda plus C2 equal to 0. And similarly for a 3 by 3 matrix, lambda cube minus C1 lambda square plus C2 lambda minus C3 equal to 0. Eigenvalues or proper values or latent roots or characteristic roots. For a 2 cross 2 matrix, already we have discussed out what is a 2 cross 2 matrix, what is a 3 cross 3 matrix. Let us see how to find out this C1, C2, C3 for 2 by 2 matrix and as well as for 3 by 3 matrix. The characteristic equation for a 2 by 2 matrix is given by lambda square minus C1 lambda plus C2 equal to 0. Let us consider a 2 cross 2 matrix in which we will have A11, A12, A21 and A22, which consists of 2 rows, column 1 and column 2. So where C1 is we have written in the characteristic equation lambda square minus C1 lambda plus C2 equal to 0. Let us see how to find the value of C1. Where C1 is the sum of the main diagonal element, that is A11 and A22. So already we have written A and D. So we written A plus D is equal to A11 and A2. And C2 is the determinant of A. So determinant of A can be obtained AD minus BC. That is first multiplying the diagonal value A and D and then multiplying from left to right diagonal value, that is B and C. Once we know the value of here C1 and C2, we can substitute in the characteristic equation and we can solve this equation to find out the eigenvalue. Let us see an example using the same characteristic equation how to find it. The given matrix is 1, 1, 3 and minus 1. Now characteristic equation is lambda square minus C1 lambda plus C2 equal to 0. Where C1 is A plus D. Where A value is 1, B value is 1, C value is 3 and D value is minus 1. So it is A and D. That is the leading diagonal. We have to add it. That is A11 and A22. 1 minus 1 is equal to 0. C2 is the determinant of A. So already we know the values 1, 1, 3 and minus 1. Just multiplying using the same formula AD minus BC. So it is 1 into minus 1 and center we have minus. We have written that minus as it is. Then this two leading diagonal we have to multiply 3 and 1. So 1 into minus 1 is minus 1. 1 into 3 is 3. So minus 1 and minus 3 will get minus 4. Now we'll substitute this value in this C equation, that is lambda square minus C1 lambda plus C2 equal to 0. The obtained value of C1 is 0 and C2 is minus 4. So we'll substitute in this equation above, that is C equation, lambda square minus 0 lambda plus minus 4 equal to 0. So 0 into anything will become 0. So we'll get lambda square minus 4 equal to 0. Or else we can write lambda square is equal to 4. Now on taking square root on both sides, we can get lambda is equal to plus or minus 2. Thanks for watching and sharing and subscribe to my channel.